You're welcome to Final Maths page. In today's lesson, we continue with addition and subtraction of vectors, but this time we are adding scalar multiplication to it. So let's begin. So we have this question here. Before we handle the question or before we answer the question, let's say something here. You have to know how to multiply a scalar by a vector. We call it scalar multiplication. So if the vector AB has component xy, then k times AB, that is k times the vector AB, is equal to kx ky, where k is a scalar or a number. So that's what we are saying. So AB has component xy. So KAB is going to be like this. That is K times AB, and AB has component xy. So you see we are multiplying this K by this and that. So you're going to get KX times KY. So that's what we're going to get. So this K is called the scalar or a number. Or, it can be any number. It can be a fraction. It can be, a negative number. It can be a whole number, positive. In fact, it can be any number. So that is the scalar or the number for you. So let's answer the question. So given the vector A with component 3, -2, and out of B with component 1, 2, we have to find the vector 2A plus 3B. So how do we do this one? We have to do substitutions in the first place. We have 2A. That is 2 multiplying the vector A. The vector A has component 3, -2. Now plus the vector, 3 times B. That is 3 multiplying the vector B. And B has component 1, 2. So that is how we can set up our expression. Now the next thing is to multiply these numbers that we see outside. Those are the scalars. So you have to multiply them by the vectors. And that is how we do it. We just multiply by everything that we have in a vector. In a vector. So 2 times 3 is going to be, 6. And 2 times -2 is going to be -4. So we're done with the first one. We come to the second one. 3 times 1 is going to be 3. And 3 times 2 is going to be 6. So at this point, it becomes, an ordinary addition of vectors. And how do we do that? Remember that we add corresponding components in our first video, or in our previous video, we talked about that. So in adding vectors, we add corresponding components. So that's going to be 6 plus 3. And we come to the y component. So we have -4 plus 6. So I've been able to add a corresponding component. Now we can simplify this one. 6 plus 3 is going to be 9. -4 plus 6 is going to be +2. So that is how we can, answer this particular question. Let's begin with our next question. So we are given the vector x, and it has components -3, 2. The vector y has components -5, -7. And that of z has components -4, -1. So how do we evaluate this one? 2x minus 3z plus y. So we have 2x minus 3z plus y. So let's do the substitution straightforward. So we have to, multiply 2 by the first vector, that is the vector x. And the vector x has component -3, 2. The next operation is minus, so -3. Multiplying the vector z, and the vector z has component -4, -1. The next operation is plus, addition. So we write it like this. We come to the next one, that is y. So y has component -5, -7. So that is how we have to set up the expression. Now let's multiply our scalars by the vectors. So let's begin with the first one. So 2 times -3, we're going to get -6. And 2 times 2 is going to be 4. We come to the next one. Here you have to be careful. This is -3, but we don't take it to be -3. We just write a minus sign here. If you take this one as positive and we multiply by the vector, don't take this one to be, -3. Take it to be 3. So 3 times -4, we're going to get -12 here. And 3 times -1 is going to be -3. Now plus -5, -7. You see, there was no, scalar multiplying this vector. So that was why we didn't multiply anything by this one. So let's move on. The next thing is to, simplify the vectors by adding the corresponding component. So let's take our x component, and we're going to get negative 6 minus negative 12 plus negative 5. So that is it. You have to check it well. Negative 6 minus negative 12 plus negative 5. Now let's come to the y component. So we're going to get 4 minus negative 3 plus negative 7. So that is for the y component. Now we can go ahead and do the arithmetic here. There's a basic one, very simple. So we're going to get negative 6 minus negative is going to be plus 12 plus negative is going to be minus 5. So that would be for the x component. Let's come to the y component. So we have 4 plus 3, that is minus negative, is going to be plus, minus 7. Now let's get our final answer. So negative 6 plus 12, what are we going to get? We're going to get 6, right? So let me write that one first. So 6 minus 5. Let's come to this one. 4 plus 3 is going to be 7, and then minus 7. So finally, our answer is going to be 6 minus 5, 1. 7 minus 7 is 0. So that is how we can, evaluate the vector or the expression 2x minus 3z plus y. So we have the vector A, which has component negative 2, 4, and the vector B also has component negative 4, negative 1. We have this expression to simplify. Wow. So we have half of A plus 2B. Let's analyze this expression. Half is multiplying everything in a bracket. So you have to be very, very careful when doing something like this. So now, let's do the substitution straightforward. So half should be outside, and I'm going to use this bracket to differentiate among the brackets that I will be using here. So now we come to the vector A, and the vector A as components, negative 2, 4, plus 2 multiplying the vector B. The vector B as component, negative 4, negative 1. So easily we have been able to, do the substitutions. The next thing is to simplify. Now this half, which is the scalar, it should be there until we are done with everything in the bracket. So I have to maintain half in a bracket, outside the bracket. Now in a bracket, we can still simplify this one. We have to multiply 2 by this vector. So we're going to get, the vector 2, negative 2, 4, plus 2 multiplying this one. 2 times negative 4, you're going to get negative 8, and 2 times negative 1 will give you negative 2. Okay, so we can still simplify the one in the bracket. Okay, how do we do that? And that is obvious. We have to add the corresponding components. So we're going to get negative 2 plus negative 8. We come to the, the y component. So that's going to be 4 plus negative 2. And we can simplify this one. Now we are going to get a single fraction, vector. Negative 2 plus negative 8 is going to be negative 2 minus 8, that is negative 10. And 4 plus negative 2, the same as 4 minus 2, which is 2. Good. So at this point, we can multiply the fraction, which is the scalar, by this vector. So I want to expand it here. So I'm going to multiply half by negative 10. So this is going to be this negative 10 times half. And we have 2 times half. And that will give me negative 10 times half is the same as negative 5. That is the half of, 10. And bring the negative there. And now 2 times half is going to be 1. So that is the answer to the expression. So that will be our last question for today. Given that the vector m has components, so we have m its component 3, 1. And the vector n also has component negative 2, 1. You have to find this expression m plus half of n. So let's do the substitutions. So you see, in this case, this scalar, which is half, is only multiplying the vector n. It has nothing to do with the vector m. So always you have to analyze the expression before you even do the substitutions. So now let's do the substitutions. So the vector m, we have 3, 1 plus half of the vector n. The vector n has components -2, 1. So we have to multiply the scalar by the vector by maintaining this one. So we have 3, 1. So we come to this one. Half multiplying, -2. You can, expand it here before you do the actual multiplication. So that is half times -2. And now we have half times 1. So that will give us this one. We have 3, 1 plus, let's come to this one. Half of -2 is going to give me -1. And half of 1 is going to be, half. So that is it. We can add the corresponding components. So we have 3 plus -1. And we have 1 plus half. So let's see what we're going to get here. 3 plus -1 is going to give me 3 minus 1, that is 2. 1 plus half is going to be 1/2. That is it. So that is how we can simplify this expression. That'll be all for today.